This question, we're shown a couple of graphs. One of them, y equals f of x, and another one is a transformation of this graph. We've taken the formula for this graph, multiplied it by a factor of k, and then added a constant a. And they're asking us to find the value of a and the value of k. So first of all, let's have a little look at a demonstration of the effect of multiplying a formula by a factor k and adding a constant to that. So let's use this setup to explore the effect of multiplying by a factor of k and adding a constant a. As it is, k has a value of 1 and a has a value of 0. So what we're looking at is y equals 1 times f of x plus 0. That's the graph y equals f of x. Different one from the question one, but we'll be able to explore the effects using it. So let's change the value of k. Let's increase it to 2. And you look at the graph, and you notice the graph is scaled in a y-axis direction. All the heights or the distances of points on the graph from the x-axis is now doubled. This distance below the x-axis has doubled to get from the red graph y equals f of x to the new graph, which is y equals 2 f of x. And let's increase it up to 3. All the heights have trebled. So there's a scaling, and we could take that value of k to 0.5, and you'll notice that now all heights are half what they used to be. The distance of this point from the x-axis is now halved. Now the only points, if you look at this graph, the only points where that scaling has no effect are points on the x-axis. So a scaling by multiplying by this factor k has no effect on the points that are actually on the x-axis. Now what if we make k negative? Well, we can see in this case where we've got -1 that the points have been reflected in the x-axis. The whole graph's been reflected in the x-axis. Where we used to have a y-coordinate of 1, we've now got a y-coordinate of -1. And we can scale to -2 to -3. So that scaling can be done on a, if you like, an inverted graph, inverted through the x-axis, or just a normal graph. So multiplying by k involves scaling of the original graph. Negative values for k reflect in the x-axis. Now what effect does increasing this constant a at the end have? Well, that's a simpler procedure. We're just translating the graph parallel to the y-axis. Now if we use negative values for a, the graph slides down. So it slides up or slides down depending on the value of a. So bearing that in mind, and remember the scaling has no effect on points that actually are on the x-axis. So bearing all that in mind, let's go back to the question and see what we can make of it. So here's the original graph, y equals f of x. There's one point on the x-axis, and this point will not be affected by the scaling factor k. So where this point goes will give us a clue as to what the value of a is. And you'll notice that the origin there, this point on the x-axis, moves up to 0, 3. So a must have a value of 3. The graph has been shifted up by 3 units parallel to the y-axis. So we know that a equals 3. So what about the scaling? Well, the way to do this would be to undo that shift and shift it back down. Let's have a look at doing that. So there's that final graph, and we've undone the adding 3. So we're now looking solely at the graph y equals kf of x. So this is pure scaling now, without that shift up the y-axis. And what's happened, the point 2, -1 has gone to the opposite side of the x-axis, so we know the value of k must be negative, and instead of having a distance from the x-axis of 1, it's now got a distance of 2. And we can check that by saying there's 2. If we replace the shift of 3, we get to that 5. So this is the point 2, 2. And therefore the value of k must be -2. All the heights, all the y coordinates have been multiplied by -2. So that -1 multiplied by -2 becomes 2. So that's 2 in there. And then adding 3 for a ends up at 2,5. K equals -2. So that's the solution, and it's all very visual. However, there is another way of doing this question. Let's have a look. Let's look at the points that are on y equals f of x and compare that with the points that are on the final transformed graph k f of x plus a. So what do we know? We know that 0, 0, which is on y equals f of x, ends up at 0, 3. We also know that 2, -1 on the original graph y equals f of x ends up at 2, 5. So let's use this first fact and see what we can work out. That means that f of 0 must be 0. If we put 0 in, out comes 0. We're on this curve y equals f of x. On the other hand, if we put 0 in place of x on this curve and add a, we'll end up with 3. That's what this tells us. X is 0, y ends up as 3. So x into this expression, out comes 3. Now combining these two, you notice that we get k times 0. We know that f of 0 is 0 plus a equals 3. And k times 0 is just 0. 0 plus a is 3. That means a is 3. And so we've got our value of 3. Let's now use the information from this second point. We know that if x is 2, y ends up as -1, and we're on the curve y equals f of x. So that means f of 2 is equal to -1. And let's move over to where that goes. That's 2, 5. So we know that if x is 2, y is 5. So k times f of 2 plus a is equal to 5. But we've already worked out that a is 3. So that means that k times f of 2 plus 3 is equal to 5. It means that k of f of 2 must be 2. But what is f of 2? Well, we know that f of 2 is -1, so it means that k times -1 gives us 2. So negative k is 2 must mean that k is -2. And there's the value -2 that we got previously. But there's two methods of solving this question. That's Mr. Corsi signing out. Hope you enjoyed the video.